Welcome, my dear students. So, today's our topic is number system, the new chapter, number system. But before going to this chapter, number system, let us go back to the computer definition. So, we know that computer is an electronic device and which stores the different types of data for the further computational operations. Okay, and it stores data. It stores different types of data and it performs the operation upon that data. So these different types of data, so what are these different types of data? It may be number, it may be alphabet, and it may be special characters. So after storing these different types of data, and upon this data the computer performs different types of activities. Okay, so these are three different types of data, and we know that the computer, it understands only one language, and that is the language of zeros and ones, which is known as binary language, the language of zeros and ones. So if you write 126, but computer will not understand this 126. It will understand the language of zeros and ones. But when we type 126, it will be converted into zeros and ones, and then after the computer, it can operate upon these zeros and ones values of this numeric value. And alphabet, if you write again also alphabet, so different types of signal will generate. For example, so if I write A, but the computer, it understands this. So this is the value of A. So if I write 6, this is the binary value of 6. So when we write 6, the computer, it understands only binary language, and when I write 6, this 6 will be converted into the binary format, and it looks like this, and the value of A, it looks like this. So in the same of special characters also. So, and these zeros and ones, the computer, it understands only the values of zeros and ones, which is known as binary language. So why it is known as binary language? So when I divide this word into two halves, bi means two and nary means number. So it understands only the language of two numbers. That is only the language of two numbers. That is zeros and ones. So it understands only binary language. So in this chapter, number system, we will see this binary, how to convert the values into its binary. So if I write 5, if I write 6, if I write 5, the value of 5 is 101. So now today we will see how to convert this value into the computer understandable language. So there is a simple mathematical process. So before going there, so in number system we have 4 different types of number system. Number 1 is decimal. Number 2 is binary. Number 3 is octal, and number 4 is hexadecimal. So I'll explain you this one by one. So first let's start with this decimal number. So let's start with the conversion of decimal number into its binary format. So in this chapter we will learn how to convert one number system into another number system. So let us see this. Okay, first before decimal. So what is this decimal type of number? So the values 0, 1, 2, -1, -3, 84, all the numbers, 86.68, all the numbers that we know is known as decimal number, and binary means the number in the form of zeros and ones. So this is binary number, and this decimal number, all the number that we know that we use in our everyday life is decimal number, and binary means 0 and 1. So binary means 0 and 1, and then after octal number. Okay, let's see. Okay, decimal number, actually this decimal number 0 to 9, these are the decimal number. Binary 0 and 1, and octal 0, 1, 2, 3, 4, 5, 6, 7. So 8 different numbers are known as octal number, and decimal, it starts from 0 to 9. It's decimal number. Binary means 2, 0 and 1. Octal means 8 different numbers. Decimal means 10 different numbers. And binary means zeros and ones. And next is hexadecimal number. So what is this hexadecimal number? So from the word itself, hexa means 16. So the number with 16 different numbers are known as hexadecimal number. So it starts from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and after this 10, so it goes from 0, 10, 11, 12, 13, 14 and 15. But see, hexadecimal number means 16 different digits. We can say 16 different digits. In decimal, 10 different digits starting from 0 to 9. Binary, 2 different digits, 0 and 1, and octal means 8 different digits, and hexadecimal means 16 different digits. But see, till 9, 10 different digits, and 10 is not different digit. It is the combination of 0 and 1. It is the combination of 1 and 1. It is a combination of 1 and 2, combination of 1 and 3, combination of 1 and 4, and combination of 1 and 5. But there should be 16 different digits. So instead of this 10 in hexadecimal, this 10 is represented by value A, 11B, C, 12, 13, 14 and 15. So after 10, the hexadecimal number is represented by the values A, B, C, D, E and F. So 16 different digits, starting from 16 different values or digits starting from 0 to 15. 15 means 0 to F. Okay. So now in this chapter, what we are going to do is to convert from one number system to another number system. So now let us see from to convert decimal to binary. And remember one thing, okay, once again, decimal, binary, octal and hexadecimal. So whenever we represent any value, any number using this number system, the notation for how to write is n, and there should be base, and this is known as base. In this way we have to write base and then n within the bracket and base or radix, you may call it as radix. So this is the syntax, this is the notation of decimal number system. So how do we write? So if you write 56, this is decimal 2 different digits, 5 and 6, and with the base as 10. Since it is decimal, so if any number whose radix or base is 10, so we have to understand that is decimal number system. So in the same way, in binary, instead of this 10, we have 1 0, suppose 1, and the base will be 2. So the base will be 2. So n is any number and base is 2. So this is binary number. So 1 0 1 to the base 2, and this octal, there may be any octal number to the base as 8. If base is 8, so we will come to know that it is an octal number. So 156 to the base 8, so it is an octal number. N to the base 16, or you may write capital letter H. Either you write 16 or you write H. So 15C to the base 16. So this is hexadecimal number. So any number, so this is the notation of decimal number, this is the notation of binary number, and this is the notation of octal, and this is the notation of hexadecimal number. So this is how we represent different types of numbers in this way. So now let us see how to convert decimal to binary. Suppose, for example, in computer, if you write 14, 1 for 14 decimal number, so convert it into binary. So what does the computer will understand? So if I write 14 from the keyboard, but the computer will not understand it as 14. So let us see what does this 14 what does this 14 it means in binary language. So there is a small calculation. So how to perform this calculation is this way. We write 14 and do like this, and then after divide with the base of binary. What is the base of binary? That is 2. So since we are converting from decimal to binary, so we have to divide this number by the base of this binary number. That, what is that? That is 2. 2 7s are 14, and then after taking like LCM, okay, 2 7s are 14, and then after just you do like this, and here you write 0, and this is what? This is remainder. So this is what? This is remainder. 2 7s are 14, so what is the remainder? Remainder is nothing, so it will be 0. 2 3s are 6. Find the LCM. 2 3s are 6. So what will be the remainder? So remainder will be 1. Then 2 1s are 2. What will be the remainder? So remainder will be 1. So after that you cannot take the LCM. So after this you have to take the value from top to bottom, a bottom to top approach. It is known as bottom to top approach. So now write, it is 1 1 1 0 to the base 2. So when I write 14, so in binary form it is 1 1 1 0 to the base 2. So that means when I type 14 from the computer, 14 from the keyboard, the computer will understand it is the form of 111 and 0110. So this is how we convert decimal to binary. So now next, let us see one more example. So we'll see with 21. We'll do with decimal number also, and 21.13 to the base 10. So now let us see 21.13. So how do we convert? So for converting this one again, so this is known as integer part, and this is known as fractional part, that we all know. Fractional part. So for the integral part we have to take the LCM, and for the fractional part there is another method. Okay, so first we have to do it by 1 by 1. We have to perform the calculation for integral part separately in this way, and this one in another way. So let us see. Okay, this one I will write it as 14. Now 21. 2 tens are 20, so remainder is 1. 2 fives are 10, remainder is 0. 2 twos are 4, remainder is 1. 2 ones are 2 and the remainder is 0. 2 ones are 2, remainder is 0. So now take from bottom to top, so it will be 1 0 1 0 1. So 21 means 1 0 1 0 1 point. And for 14, so what we have to do for 14? So here we are dividing, and for 14.14 we will multiply it by 2. You have to take 0.14. We have to take the decimal part also. So before this one you can write 0 also. So it will be 0.28. And now after this, take the fraction part and again multiply it by 2. So 0.28. I'm not taking this 0. Actually I am taking only 0.28. If nothing is there, so we can put 0 to 0.56. Take this 56, 0.56. Since nothing is there, so I am putting it as 0. But I am not putting this 0 out here. Remember that. So it will be 2 6 are 12, 2 5 are 10, 2 6 are 12, 1.1. So after point, what is there? 1 2. See, I am not taking this 1. I am putting 0 if nothing is there. 0.24 into 2, 0.48. Mm-hmm. 16 to 4 is 8. 0.96.